Okay, I found some of us are still having trouble with how to find the limit of a Riemann sum. So I'm going to use first an example to illustrate this process, and then we'll work out a problem again. So let's look at first a sum like this one. You have 1 and you have plus 1 squared over here, and you have over here 2 and plus 2 squared. Keep going. So you can see this is something we might see in the Riemann sum, and we have n over here plus n squared like this, right? Now, to add up this sequence of numbers over here, we use the associative law. Okay. So we can add up these things first, 1 and 2 and 3 and 4 and n. So this is the same thing we can easily see. We collect these terms first, 1 plus 2 and plus 3, and keep going, plus n. Then we add up the square terms, 1 squared and plus 2 squared, and keep going like this, plus n squared, like that. Now, in terms of the sigma notation, this is what we have. If you look at this sum over here, this is exactly using the sigma notation. It's the sigma over here. I goes from 1 to n. And the first one is I, because 1 and 2 and 3. So this is I. So what you have over here is I over here. Okay. And then second one over here is I squared. So you have over here I squared. Okay. So what we have over here is simply add these i's first and then this one. So what we have is like moving the sigma sign inside this sum. So like this one over here, I over here. This will give us the first one over here, and then plus sigma I from 1 to n, and then I squared. So from here to here is just our notation, the sigma notation, and from here to here, sigma notation as well. Now, let's imagine we have something just slightly different, and we have some constant coefficients in front. See, we have something like this over here. The first term we have, say, 2 times 1, and the second one, let's say we have over here 3 times 1 squared, like that. Okay, so it's times 1 squared. Okay, and second term over here we have something like this. We have 2 times 2 and plus 3 times 2 squared. And you can see the pattern over here. What it means is that we are just multiplying 2 to the front over here, 2n, and then we have 3n squared. Okay, and use the sigma notation. This is simply sigma over here, and I goes from 1 to n, and we have over here is 2i, and then plus over here we have 3i squared. So by the same property, and here you can pull out the constant 2 and 3. So this one over here is equal to 2 and times 1 plus 2 and plus 3, and you keep going over here, 1, 2, 3, and we have over here n. So this one over here, this sum, collects all these terms, 2 times 1, 2 times 2, and 2 times n. And then we look at the second part and pull out 3. So this is going to be 3 over here, and then we have 1 squared and plus 2 squared and plus n squared, like that. So that's how we regroup these terms. And you can see over here the corresponding notation using the sigma notation over here. This is what we have. We have sigma twice over here, and I goes from 1 to n, and I over here. So it's like we pull this constant 2 out of this sigma sign, and then we have 3 over here. Sigma I goes from 1 to n, and then we have I squared. Okay. Now, what's our next step? We know the formulas for these sums over here. So what do we have? This one over here, as well as this one, is twice n plus 1 over 2. So that's the sum over here. And then plus, again, we have the formula for this sum of squares. So we have n and n plus 1, and then we have 2n plus 1 and divided by 6. So what we have over here is 2 times this one over here is n times n plus 1 over 2, and then this part over here is this one. So either way, if we use sigma notation, this is how we get over here. And if we use this explicit expression of this sum, this is how we get over here. These two are just the same. This sigma over here we have is just the notation. Alright, now let's go back to the Riemann sum. How can we apply this calculation over here to find the limit of a Riemann sum?